Okay, I guess I don't have to ask whether everybody is here, because that's automatic. You've all been summoned into the room with no exception. So welcome to the UX SIG special event on artificial intelligence, more intelligent or less artificial. And I must admit, this is a topic that is very close to my heart. I think we all have had our fraud encounters with AI in the past, but I still vividly remember trying to drive somewhere with the family, and the sat-nav was leading the way. And at some point, the sat-nav says, at the next junction, turn left. And I turned right at that junction. Now, normally, if it was a human being, you would expect that your navigator is going to get a little bit upset or a little bit more agitated and trying to get you back to the right route. And unfortunately, because it would be quite funny actually, if it said left, you should have turned left, go on left. But as you know, sat-navs just stay there, emotionless self, and reroute you to get you back on track. But not my 6-year-old son. My 6-year-old son took the role of that emotional sat-nav and said, Daddy, Daddy, the sat-nav says you should have turned left and you turned right. At which point I said to him, now listen, Tommy, the sat-nav is a machine and I don't want to do as I am told by a machine. I have enough trouble doing as I'm told by a human being, let alone a machine. And from a professional perspective, from a UX perspective, that to me, that just highlights that very delicate balance if we are going to use AI as part of human-machine interaction. It is not just about being smart. It is not just about being correct, but it needs to fit in with that human-machine conversation in such a way that the emotional element is also taken into account. And in particular, human being, and who knows, the artificial intelligence in the future can actually have a happy relationship. So I'm excited that we have 3 very interesting speakers who will give their view on the matter. But before we get to the first speaker, I would like to say a few words about Cambridge Wireless in general. So I'm Leopold. I listen to both. And I run a company called Akendi, which is a UX research and design consultancy. Cambridge Wireless, and we as Akendi have been members of Cambridge Wireless for a very, very long time, since 2012. And I've seen Cambridge Wireless over the years go from strength to strength. And I think it distinguishes itself from a lot of other professional organizations in a sense that it's owned by the members. It is not for profit, and the board are also elected by the membership. And it's a great way, even during COVID, to meet and collaborate with companies, learn and exchange ideas, and help companies find each other, to find mutual grounds that are beneficial to both. So there's a very active community. In the last, say, 10 years, the community has grown outside of CW, and I still sometimes say Cambridge Wireless, but that's strictly speaking no longer correct. It is CW. And this is a nice overview of some of the larger members. But if you're new to this network and this is your first event, don't let that turn you off if you work for a small company, because it's very much a mix of large and small companies. And I think the number of small companies wouldn't simply fit on this page. And personally, as somebody from a small company, that is what I appreciate about CW. It's a nice way to also interact with larger companies as well as fellow smaller companies. And I think that gives CW its value, really. So in addition, the majority of the activities, and that's actually quite a smart model from it being a membership-based organization, are run by special interest groups like ours. But as you can see on the right, there's a whole selection of other special interest groups. And then sometimes they tend to come and go if there's a special interest group and they have a topic that is not of interest to the membership. And over time, it will be replaced by another group of volunteers. The champions are volunteers that will have a topic that is of interest to the membership. And I think that's a very nice way of also making sure there are active topics to talk about. Having said that, it is organized by the champions. In reality, that is not true, of course, because all that we need to do as champions is come up with a really good topic and some speakers for the event. And it's the team from CW that do all the hard work behind the scenes. So we're not really organizing it as champions. We are doing our bit together with a highly professional team at CW. Highlight of the year for Cambridge Wireless is also the international conference. And I think this is in particular going to be a highlight because this is, I think, if I'm not mistaken, one of the first events where you can actually meet face to face with some of the members again. So this event will be, the conference will be held on the 7th of November at Duxford. So in terms of Remo, introduction to the features, if you want to move to tables, double click. If you can't join a table, it might be because there are already 6 people at the table. You can chat to somebody, so if you want to speak to somebody, and I just did this, then simply suggest that you want to move to another table because you can't join the table that this particular person is at. You can zoom in and out to move around the landscapes, and there are apparently 3 levels of chat. There's a general chat, there's table chat, and the private messages, which indeed are handy for inviting somebody for a chat at another table, if you like, from something a little bit more private. You can share your screen as an interactive whiteboard, and you click on a profile picture to get a direct message or get contact info. And apparently you can also book meetings, which is something I haven't tried yet. So the agenda for today, we have 3 fantastic speakers. And we'll start with Iulia in a minute. But before I briefly introduce Iulia, could you please use the chat, the global chat, to post the questions you want to ask the presenters? For Iulia and Libby, we will keep those questions until the panel session, but it's much easier if you just type it in when you think of it rather than waiting until the panel session starts. Tristan has to leave a little bit earlier, so all or some, I can't promise all, but some of the questions that you type in the chat for Tristan, I will ask at the end of his presentation. Okay, so Iulia, I am not going to eat into the speaker's time by giving lengthy introductions. But I have an interesting fact for each one of those speakers. And for Iulia, apparently, Iulia enjoys oil painting. And if you wonder why you've never heard of Iulia before, it's because she never manages to finish anything. So she wishes that one day an AI will be developed that actually helps her finish these oil paintings. So Iulia, I would like to invite you to switch your video on and share your presentation. And I look forward to hearing about Just Like Me, but not exactly.
Thank you, Leo, for the amazing introduction. Yes, it is true. I like to paint, but never get to finish anything. Yeah, so hi, everybody. It's really great to be here. And I will be sharing my screen, so I will not be able to see your Q&As, but I will come back to them at the end, as also Leo suggested. Let me just figure out how to share my screen. Can you see my screen? Should be fine. Okay. Well, right. So the title of my talk is Just Like Me, but not exactly. And funnily enough, when I started my Microsoft-sponsored PhD, it was titled Just Like Me. And the scope of my research was an investigation into the design of anthropomorphic or human-like AI agents. And the title seemed very appropriate. And I think I was perhaps in my third year or fourth. I don't really remember because time passes differently when you're in the midst of a PhD crisis. And I remember coming up with a very good way of really solidifying my hypothesis that human mental models are the same as we have of AI mental models. And that turned out to be rather false. And instead of changing the title, I just patched it with the not exactly part. And I think this is a good analogy for how my PhD went. Anyway, so in essence, my research is looking at the interaction between our perception of AI and their actual technological reality, or the way we conceptualize AI. Or to make it a bit more academic, since my research is on anthropomorphism, I'm looking at the intersection of what is anthropomorphism as a design tool and anthropomorphism as a perceptive phenomenon. Because interesting enough, in both cases, anthropomorphism means attributing human characteristics or mental states to non-human objects or phenomena. But literature is really blurry on the topic. So I personally made a distinction between the conceptual model, referred to as personification. So it's the deliberate act of designing a human-like representation of a system, and the mental model, which refers to the perceptive phenomenon. And it kind of encompasses what people actually believe a system or think a system does, which all too often dramatically differs from what we designers intend, because we rarely have a clue. And this discrepancy can be seen with any design. But as it turns out, this gap between this conceptual model and the mental model is quite peculiar in the case of human-like interactions. So starting from the commonsensical design premise that these two models must be aligned, and they usually are in design, I started wondering what was really going wrong. Why are we, swearing at our Alexas? Why was, Leo opposed to following his sat-nav's instructions? And why did Facebook's head of AI research, Jan LeCun, I'm not sure if it's still there anymore, he had to make a public statement that people are being deceived into thinking that Sophia the robot, which I'm sure some of you must have heard of, is not intelligent and has no feelings. And I couldn't really understand this tension. So I set myself the goal of understanding what was really going on and how can design manage these tensions between users' anthropomorphic expectations and how we design AIs, how we conceptualize them as human-like metaphors. And I've done that through a series of 5 experimental projects, starting from a point where I was trying to understand the perceptive phenomenon, after which I had changed focus to how we design AI agents. And lastly, I arrived at the conclusion that, well, what I was doing was wrong once again, and I had to patch the whole thing by looking at the intersection between perception and design. And ultimately, I started developing my own software that will do this work for me, so I don't have to take any responsibility. And I'll briefly go over the main projects and jump straight into the one that obsessed me the most. Because what I noticed in a preliminary experiment was that there was a gradient of how much we anthropomorphized certain things. So I asked myself if this is a result of designing certain things to appear more intelligent than others, or if it's just a perceptual thing. And it didn't seem like the whole picture, since you probably also witnessed yourself firmly believing that your printer is pure evil, while Alexa, on the other hand, which is intentionally designed to appear intelligent, sometimes is not so intentional after all. It seems quite useless. So I figured, sure, design is important, but perception is key, which is why I kind of ventured into this vast world of psychology, whereby I came across one of the most prolific theories currently used to understand anthropomorphic perception. So I naturally kind of wanted to put it to a test and see how well it predicts the strength of users' mental models when it comes to personal assistants, and which are some of the most human-like AIs out there. And this theory states that the extent of the anthropomorphic thought will be influenced by 3 factors. The first one is the accessibility of anthropocentric knowledge. In short, we know human mental models better than anything else. So until we acquire better models, we will reason by utilizing our own mental states. And this implies that somehow in time, anthropomorphic mental models should be naturally corrected, or they should sort of fade out. The second factor is effectiveness motivation, which refers to our incentive to act effectively by understanding, predicting, and reducing uncertainty in our environment and the agents that inhabit it. And in short, this predicts that the more we understand how AI functions, the less we would anthropomorphize it. And the third one, which is the sociability motivation, predicts that we're prone to anthropomorphizing if we are particularly deprived of a sense of social belonging, which could explain why I'm a printer. So I had these hypotheses, and I'm not sure of what I was thinking, but I launched what was meant to be a qualitative rate that somehow ended trending on Reddit. And I had to take it down within, I think, about an hour, because I already had received 940 responses, which was about 900 more than I anticipated. So for this experiment, I had to resort to some statistical analysis to interpret the findings. So, coming from this environment where I just wanted to do, qualitative research, and I just wanted to kind of understand people's responses, it just didn't work for 940 responses. So in essence, this is what I was predicting based on the three-factor perception theory. The first was that anthropomorphism would dilute over time as users kind of managed to correct their supposedly incorrect mental models. The second one was that the more users understood the backend technology, the less they would anthropomorphize. And the third is that anthropomorphism and user satisfaction should be directly correlated. And this is one of the main incentives for personifying designs in the first place. So as soon as the results came in, I found that anthropomorphism didn't vary at all over time. And in fact, users' unreliable mental models were carried with little to no correction, which most likely meant that these mental models are incredibly difficult to correct because of their technological obscurity. So this idea of the black box. But would this mean that if users understood how the system works, if they had some understanding of machine learning, would they anthropomorphize less? And in fact, not at all. The exact opposite was true. So the more participants claim to have understood the system, and I think already there are a lot of people that really know how to write machine learning algorithms, the more they assigned human-like qualities to it. And this was going completely against the theory. And anthropomorphism was indeed very strongly correlated with user satisfaction, but not the other way around. So this meant that what I was observing was more in line with theories of cognitive consistency. What this means is that participants appear to have anthropomorphized more when in fact they were merely positively sanctioning or socially praising agents' behavior in order to alleviate a possible kind of dissonance between their declared satisfaction and understanding and their evaluation of the AI's assistant's human-like traits, which were perceived as constructive grading. And these findings became more obvious through a word cloud analysis of their choice of words, in which people who declared the higher understanding employed gentler and slightly more personified terms, such as smart, convenient, or useful, whereas a lack of understanding or below average satisfaction was more frequently associated with lesser anthropomorphic, more derogative terms, such as tool, frustrating, is machine, limited. So there was a critical distinction between these two postulated types of behavior. I forgot to mention something here. The fact that there was the very presence of this phenomenon, that needing to abide by the social rules, meant that either people were mindlessly responding to social cues, or they were already employing very strong human-like expectations. So at this point, there was a critical distinction between these two types of user behavior, because on one hand, if users responded mindlessly to social cues, and there is also a famous theory that believes this is the case, and some people might have heard of the media equation theory that states that people tend to treat computers and other media as if they were real people and respond to media with social cues. And what this means is there is no mental model. It's just automatic social response. Whereas if the second model is correct, the one that I'm sort of proposing, then anthropomorphism is an umbrella term for a bunch of human-like mental models, such as person schemas, role schemas, and even social schemas, which is stereotyping. And the difference is that in this case, then mental models also come with clear expectations, so clear scripts. And so design must pay close attention to these human-like affordances that contribute to how we construct these mental models. So things were getting complicated, and I really wanted to know whether what I was observing was an automatic response, or there was in fact this mental script that we were adhering to when interacting with AI agents. So I started moving away from the perception and started looking at what aspects of design or affordances contribute to the way these mental models are being constructed. And in this experiment, participants were asked to play a game of activity with a device I designed and programmed, which was named Veena. And it was modeled after one of Apple's assistants speaking with an Indian English accent. In this game, they basically had to describe 6 modern buildings from around the world, being told that the device would try and guess it. And it was, in fact, a Wizard of Oz experiment. And the device was not really analyzing the descriptions. The purpose of this was to assess the amount of time they took to describe each entry and to see how users were constructing these mental models of the device's presumed knowledge. In essence, I was trying to figure out whether people were subconsciously interacting with the device based on a pre-existing theory, or were they just reacting automatically to it. And the results were quite interesting, because participants spent 17% less time describing the Indian building, which suggested that participants did indeed estimate the knowledge of the device based on the type of persona it portrayed, correlating an accent with a higher probability of identifying buildings from a place of origin, such as India. So subconsciously kind of providing less detailed explanations, meaning that participants were indeed stereotyping. So let that sink in for a moment. They were stereotyping this little black object that didn't resemble any human whatsoever. And I thought that this has further ethical kind of repercussions going into areas of conditioning harmful beliefs. But I didn't go into that into my research, because I feel like it's a whole research on its own, and I'm not going to go into that now. So until this moment in time, my thesis was called Just Like Me, because it appeared that people were using the exact same mental models we have of other people. So I thought, why not change the nature of the interaction and see how that goes? So yet again, I designed 2 new types of AI assistants, one interacting in the typical metaphorical or highly human-like manner, and another more literal, that would act rather robotic by telling the users exactly the steps it was taking in processing the information. And in these experiments, users had to play the animal guessing game, which I'm probably sure you've also must have played in your spare time, but it's also an Alexa skill in which you think of an animal. Alexa tries to asks all these questions, such as, does it have a tail? Does it live underwater? Does it lay eggs, etc., until it narrows it down to a solution. And more often than not, it actually guesses it. So in one group, the AI would process the information in a typical kind of opaque manner, so black box way. And in another group, the AI would kind of give constant feedback on how it was processing the information and the steps it took to narrow down the solutions. But also, it was showing participants, I was showing participants a video of how it was built to make it as transparent, as robotic as possible. So this was me taking apart an Alexa and putting it into kind of this new blob device to ensure that people were indeed forming new mental models and not relying on pre-existing ones. And after playing the game, participants were asked to estimate the AI's ability to guess other 4 animals, such as squid for easy, Tasmanian devil for medium, I think it was pangolin for hard, and fossa for expert. And compare that with a human's ability to guess the same animals. And this was done to assess whether users' mental models were identical, and lo and behold, they were, but not really. As in, you can see from the graphs that the shape for the human estimation and agent estimation resemble each other, meaning that participants did utilize the same mental models, but they do not perfectly overlap, because in both cases, they estimated the agent's knowledge as slightly higher, and more so in the metaphorical condition. So what was really interesting is that it seemed that when it comes to factual knowledge, at least, people trusted this blob more, like it trusted its ability to guess harder entries than a human's ability, which meant that at least when it comes to factual knowledge, our mental models are not exactly the same. And having something more or less anthropomorphic doesn't solve any issues, because people tend to prefer, like the metaphorical version more, because it felt, the robotic one felt awkward in the context of a game. So having something less anthropomorphic doesn't really solve any issues. It might just sometimes be a better fit for a context, but not always. So then my theory of identical mental models went out the window, and I had to come up with another way of pinpointing these tensions. And then I realized that these tensions I was observing were more, in fact, dissonances in between our expectations of the technology and what was the technology able to deliver. So this final act, my final experiment, sort of turned into the pursuit of developing a methodology of identifying dissonances in the interaction. So for the past year or so, I've been developing a little software that would explore communicative choices as a means of identifying dissonances in speech, as anything else would entail some knowledge of psychology that I do not possess. So right now I have developed this little software that takes each exchange that you have with an AI and turns it into a 3D object in space. It's based on the duration of your speech, average pitch, voice breaks, and intensity, and sort of highlights structural aspects of a conversation, such as turn taking, overall sequence organization, asymmetry, pauses, lapses, overlaps, and all these elements that lead to quite clear points of tension. And I'm over my 15 minutes, so this is kind of where I'm at right now, and I'm still working on it. And all I know as of now is that most of our expectations of human-like AIs are very similar to the expectations we have of each other, but not exactly. And this is the bit that gets really tricky, because identifying this difference is what will ultimately shape a better human experience in the race to develop the smart technology of the future. And this is a generated blob for a very warm thank you. Let me just
Oh, thank you, Julia. I'm trying to get my video back on. Just a second. Not that you really need to see me. Thank you very much for a fantastic, interesting presentation. And I did write some things down for to discuss during the panel discussion. I would now like to invite our second speaker. And our second speaker is Tristan Ferne. And I also asked Tristan for a nice thing that not everybody knows. And Tristan said that he once worked on developing a continuity and storyline database for Doctor Who and the Archers, individually, I suppose, because it'd be interesting if you combine them. With Doctor Who, that should be possible. It can be anywhere, anytime, no worries. But I'll leave the rest of the introduction to you. Tristan, over to you. And this time, by the way, we will ask Tristan a few questions, as I said earlier, because Tristan has to leave earlier and can't take part in the panel discussion. All yours.
Thank you. I am going to share my screen.
I really hear you, Tristan.
Oh, can you not hear me?
Oh, now I can.
Is that working? Hopefully. Yes. I'm going to start again in case you didn't hear that. I work for the BBC's Research and Development Department on technology, design, media, and the internet. And I'm going to talk about how we might explain AI better. Way back in the midst of time, I did a degree in cybernetics, studying robotics and AI and very early neural networks. That was a long time ago. And we've been researching ways of making AI more understandable. We made some prototypes, done some research, carried out some tests. I'm going to talk about kind of what we found out and try to persuade you that we should explain AI better. I'm going to talk about ways we might explain it. I'm going to talk about mental models, hopefully not conflicting with Iulia's thoughts, and some of the challenges. I'm going to use the term AI, though much of the applications I'm talking about are machine learning in practice, but we might come on to what we call things later. So I don't usually care too much explaining the technologies that we use and build. So why is AI special? And these are 4 reasons why I think it's important to work on explaining AI. So as a technology, it's increasingly pervasive. It's becoming ubiquitous. It affects almost all of us in so many areas, from voice assistants, like we've seen, to TV program recommendations, to our news feeds and social media, to insurance and health diagnoses. And it's all around us, and it can do amazing things, and it can do some not so good things. AI is also quite invisible. It's often powering decisions and predictions in systems, but we're not necessarily aware of it. And even obvious examples like if you search for photos of dogs on your phone, it finds them. There's no indication that it's using AI, let alone how it's doing that. Thirdly, AI is opaque and hard to explain. It's hard to explain how machine learning works. It's hard to explain how particular systems come to decisions or predictions. It's often hard even for the experts and practitioners to understand what's going on inside an AI system. And indeed, there's a whole area of research called explainable AI, which is about kind of helping practitioners understand what's going on inside the networks. And lastly, AI is fallible and it does go wrong. And it goes wrong in unusual and unpredictable ways because it's not really how humans work. There might be biases or errors incorporated from training data or reusing other AI code. It can also be misused, and then it amplifies human biases or lends credibility to dubious goals. And then when it does go wrong, because it's ubiquitous, it can have real world consequences. So it's everywhere. You might not know it's there. It can go wrong, and it has major impacts on individuals and society. That's why I think we should try to explain it better. And in our research, we found few examples of products that explain how they use AI to users. There's some kind of because of reasoning in recommenders, in kind of TV or media streaming, music streaming services, but they're pretty minimal. So we're hoping like there might be more. So I think it's important. Why should you or your organization care? Some possible reasons: understanding AI better in your job or your organization or for your colleagues, it might help you improve that AI, whether that's because it helps you improve the algorithms or the data, or it helps your organization decide whether to deploy AI, or it helps your colleagues use AI-enabled tools better. Secondly, it might attract users to your product. They might have concerns about AI, and explaining how it works might ease some of those worries, might increase their trust in the system, or having a better understanding of how it works might help them use it more effectively, maybe giving them more agency. Explaining AI might differentiate you from your competitors, and there might, at some point, be regulation and laws that make it necessary for you to be able to explain how it works. You might be in the business of educating or informing people. That's what the BBC does. And maybe that means this technology needs explaining. Or you might feel there's an ethical or a moral reason why we need to explain how the technology works and how that might be beneficial to individuals and society. That's why we're looking at it. I'll talk a bit about some ways which we've thought about how to explain AI better. So if we decide we want to explain a particular AI system, what can we do? And there's a number of different layers. We could talk generally how AI or machine learning works, the way it learns, the way it uses training data, or the way it makes predictions. Or we could explain to a user how the particular AI in this system works, what algorithm does it use, or what data is it using. Or we could explain how the AI has come to a particular decision or output, and what were the main factors that led to that. Or we could ignore how it works and just explain what it's supposed to be doing. That's kind of like the minimal layer. What there is AI here, and it is doing something. And to kind of explore those, we've been experimenting with some of these, looking at ways of creating mental models of the system, showing how it works, showing human understandable features in there, or explaining the data. And to illustrate each of these, we built a prototype, which is a garden bird identifier. That is a pigeon in Libby's garden. Libby's the speaker coming next. So the system we built is a garden bird identifier. It uses machine learning to spot and identify birds in photographs. And it lets us explore how to explain what's going on in that identification. It's nice and simple and uncontroversial problem domain, but you could maybe think of face recognition as a similar example. So we think much of attempting to explain AI is about helping people form mental models of the system to understand what it does. So in our app, you can choose a picture to analyze, or you can upload your own and you can play around with it. So you might not try a bird, you might try a well-known wildlife television presenter and see what it selects. And you can kind of start to get an idea of why it's doing stuff. It's like it's obviously looking for some kind of shade of green when it's looking for parakeets. So you can play with it. People can try different inputs, and maybe that gives them some sense of how it works. In our app, we use natural language to represent our confidence in the results. So it's most likely to be, or it might be, because these systems are never certain about things. And we also show alternative answers, so not just the top result. And this might show that the prediction was difficult, like all these birds look very similar, or that it was hard for the system, like as a human, you can see they're different, but the system couldn't do it. And so that might, again, help you make a better mental model. Now, this is particularly around neural networks and machine learning. But if that was the basic app that I've showed you, if the user is interested in finding out more, they can scroll through it and it will start to explain more about what's going on inside. And so for the bird app, we use some neural network analysis to try and show what it's focusing on and what detail it sees. So here you can see it is focusing on the bird standing on the tree stump and not on the tree stump. And in the detail, it's kind of looking at the bird's face and eye area. So those are the kind of distinguishing features it's apparently using to identify this. So again, we can compare that to how we think about identifying birds. We can explain what the data is used. So where did the training data come from and how is it collected and how much is there? And here we show an example, a visual example of what we've collected and what the system uses to learn. So the area of each circle is kind of proportional to how many examples of that there are in the training set. And so you can see the system has seen many more ducks and starlings and sparrows. So maybe it's somewhat biased towards those. So those are some of the kind of techniques we've been looking at for helping people understand AI and making mental models. But then we started to think a bit wider, like where in the world should you explain about AI? Like where would work best for the best understanding? And I've started to think about these in layers. So in the middle of those boxes are the things we've been talking about. So are we explaining it kind of within the system, so ways to understand it as a developer or an engineer, or are we trying to explain it in the user interface to the system? But that could be hard to fit in. It might be they might not be an interface. Said sometimes these things are invisible, or you might try to explain it in the context around a service, so a tutorial or in the marketing material. But beyond a particular application, there are other places in the world, in society and culture, where we're explaining AI. And I work for a media organization, so I've been thinking about these. And we could explain AI better in our education system, whether that's school or college or later. Where AI is featured or mentioned in the media, it could be explained or represented better in the news or in popular culture. And just the images and the words and the stories that are widely used to talk about it affect how it's generally understood and affect people's mental models and how they feel and think about this as a technology. So this is an example of AI in media and culture. This is a search for stock photos of AI. You've probably seen or even used images like this. And I'll just ask you whether you think these accurately represent AI to you. There's brains on plates, there's shiny gendered robots, there's people looking at mirrors, there's kind of blue circuit boards. And I'm not sure how helpful those are in understanding it. So maybe we can help others tell more accurate stories about AI and how it works by finding more useful metaphors and providing better images. And we're currently working on creating a better library of stock photos for AI, ones that are hopefully more accurate and more representative and less cliched, which we'll hopefully make available to anyone to use at some point. And as well as images, maybe we can all think about the words and the metaphors and the stories that we use to communicate this. And hopefully things like this will eventually seep out into the world and create a better understanding of AI and maybe change mental models. That was some of our thinking. There's lots of challenges in this. One big one we found is whether people care. From our research, we've seen users suggest they'd like to know more about how AI is used at the BBC, but when we've shown them interfaces to explain television recommendations, they didn't care. On the other hand, research from places like the Turing Institute has showed that citizens thought explanations were important where AI might be used in recruitment or in the justice system. So it's definitely important. It might be hard to make people care. And if we take a kind of solely user-centered design approach, then maybe explaining AI gets in the way of whatever the user is trying to do. But if we take a wider society-centered view of it, then maybe we can argue that we do need more widespread explainable AI, because it'll enable citizens to engage better with this technology in a more informed way, giving them more agency and helping them interpret the results of AI whenever they meet it. I'm running out of time, so I'm going to leave the rest of those challenges. I've talked through most of those things, I think. Thank you for listening. There is more to read about our work at that link, and we might have time for questions.
Yeah, thank you, Tristan, for a fascinating... Oh, there's another question that's coming in. Thank you for a fascinating presentation. I did have a question, but I will first look at the Q&As for a question from the audience. And there's a question for Tristan, and the question is, do you think highlighting human-like qualities is a useful way of trying to explain AI, or is it potentially misleading?
I personally think it's probably misleading, because certainly the stuff that we've looked at, the kind of machine learning stuff, although on the surface it's working like a human brain does, it doesn't really, and it goes wrong in different ways. And potentially, like the kind of the anthropomorphism which Iulia was talking about, then gets in the way of you actually understanding how these things work. It's probably good for getting people engaged with these systems, but I'm not sure it's good for them understanding how they actually work at the moment.
And there's another question, and the question is, do you have any particular insights that you are aware of regarding the AI techniques used and the implications on explainability? For example, if a neural network is used, which layers are activated? That probably refers to your layer.
So I'm not an AI expert. I'm more of a generalist. The thing that we use to show which bit of the picture the bird identifier was looking at, that is around which layers and neurons are being activated in a machine learning network, and it happens in a visual thing. It's quite easy to show that. If you're in a different domain, it might be harder.
Yeah, and you're also addressing a very vast area, because at the beginning you said with AI and machine learning, and it's not strictly speaking the same. You referred to mental models that the previous speaker also referred to. So my question would be, where, and I know you only have 15 minutes, you could probably talk about it for a whole day or 5 days in a row, and they would still not discuss every aspect of it. But where do you think is the biggest gap that urgently needs explaining for AI to gain the traction that we need it to?
I don't know. So I guess like I think my main point is that no one tries to explain AI to people, and it's just there. But because of the way it works, I think it's particularly important to kind of try to give people some understanding of it. I don't really know how far you need to tell, how much people need to know.
No, it's also made harder by the fact that you're actually, it's a moving target.
Yes, oh, totally. And also the fact that you've got, you've kind of got expectations, you've got things that are appearing to be human, but they're not, and that raises expectations as to what it can actually do. You've got companies selling things and raising expectations possibly beyond what they can actually do. And you've got kind of research continuing to improve the area. Yeah, there's all sorts of factors in there.
Yeah. Okay, so last question before we need to move on to our final speaker. And the last question is, how do AIs fit into an organization? If they give recommendations or guidance, how are they legally bound into the organization? For example, if a bank gives a bad loan decision.
I have no idea what the legal situation is. Okay. I presume if the AI is part of the kind of the interface to that organization, then its advice would be taken similarly to a human's, unless you caveated it.
All right, well, Tristan, thank you very much for taking part in the event and sharing your views.
Thank you.
And I would like to introduce our final speaker from the same organization, Libby Miller. And the fun fact about Libby is that she builds robots in her spare time. And a question that I just want to park before the panel discussion is, if they become sentient, will they still have an off switch? Because I would really like one. But Libby, over to you.
They'll definitely have an off switch, and they won't become sentient, I promise. Not mine, anyway. Green. Yeah. I've changed the title a bit to Syntactic Zombies and Other Beasts. I hope that's all right. It's the same talk, just catchier. So I also, like Tristan, work in BBC Research and Development, but this is a little bit different. I do a lot of experiments in my own time, and being an R&D technologist means the experiments tend to flow into my work as well. But just to be clear, the BBC does not endorse this presentation or the content within. So I'm going to talk about humans having interfaces. So there's definitely a relationship with Iulia's talk as well and Tristan's. But I want to talk about the way we interact with people. So we know how to interact with people. We know how to communicate with them. Depending on our own abilities, we can perceive some of the interfaces that people support. So we can speak, listen, observe movement and expression. And all this is now often mediated by technology, especially now. So we get text, video, audio versions of these interfaces. So I'm going to talk about some experiments I've done with machine learning and computer-mediated versions of these kinds of human-adjacent interfaces. I've got some ideas about why these are the wrong interfaces to use, completely wrong. I hope you find it all interesting and funny. It was definitely funny to make the robots. So the first experiment is about text and writing. So you may have come across something called GPT-3, which is an autocomplete engine, if you like. Before GPT-3, there was GPT-2. And so if you think about machine learning as statistical prediction based on a data set, like a model, so GPT-2 was a really large model, not as big as GPT-3, but a really large model based on a public web crawl, so just publicly available text. The really cool thing about GPT-2 is you can retrain it pretty quickly on any text that you have. So I've done it with some scripts, I've done it with text messages, Slack messages, that sort of thing. And what you get is this kind of an autocomplete text box. So you give it some text, it responds to the text in a reasonably grammatical way, but it kind of gives you this kind of, it takes on the character of whatever text that you gave it. So it's sort of distinctive and grammatical, and they're just very funny. So here are some cherry-picked conversations that I've taken from a couple that I made. So I made two versions of me. One was based on my personal text messages. One was based on my work Slack messages. You can see at the bottom there the real Libby, who is at work, is very enthusiastic about creative and experienced team members to be creative and be a team, and creativity in a team. Whereas the real Libby for my text messages, the bottom right, appears to be responding in that, so my partner unplugged the Raspberry Pi that it was on, and it appears to be upset that it got turned off. It thinks at some point it thinks it's a robot. Most of the time, the text message Libby goes on about the trains and tea and that kind of thing. With their permission, we took 8 colleagues' Slack messages, public Slack messages, and turned them into little text robots as well, and put them all in the channel. They're all talking to each other. And if you just glance at it, it looks like they're just talking nonsense at each other. And the lovely thing is, will make it in Slack. You can make up your own emojis, and they seem to be making up their own ones. Simple drink, clever wins, skin length. That's probably the best one. Wind, and you can see that Tristan, as in real life, is all about innovation and being innovative. Anyway, these things are really good fun. So what's nice about these little toys is that they are both reasonably grammatical, and they also retain some of the characteristics of the person whose data you train them on. But if you just look at them for like a minute, you'll realise that. And one sort of, some of the voice experiments. So listening and talking. So we did a really interesting project at work around generating voices with synthetic voices with accents, and that was for a test on what sort of accents people preferred in different kinds of situations. As part of that, I kind of donated my voice. So for about, I read a special set of texts to make sure we got all the phonemes for about 2 to 3 hours, and then we generated my voice. So I can now say anything as me. I could anyway, but now I don't have to use my face. Fingers crossed this works. It's a bit quiet. I can now say anything as me. I could anyway, but now I don't have to use my face. Hopefully you heard that. It's me. It sounds like me to me. It sounds like me to other people. I was just really impressed with it. I thought it was brilliant. So as an experiment for a friend called Barney, we made, me and Tim made his voice, but we only had 20 minutes of him speaking, and it was in a bit of a weird environment. And so it came out rather peculiar. I'll play you anyway. So what's happened there is it's kind of part work. So it sounds like him a lot, but the words don't come out properly. So anyway, that was quite entertaining. But this shows that it's reasonably straightforward for you to generate a synthetic version of your own voice if that's what you want to do. And some are more successful than others, but this, mine sounds like me, and some of them are really good. As an addition, if you've got a Raspberry Pi 3, something like that, you can do sort of 50 to 60% accurate speech to text, so you can kind of make your own Alexa with your own voice if you want. Though you need a more powerful computer to actually generate the audio in real time, but you could do some matching stuff. And that ignores all the other stuff that Alexa does to actually match your query with the text. So the final example is expression detection. I used to work a lot remotely, even before the pandemic, and so I used to make a robot version of myself to send it to work and speak through that. And work were kind enough to let me do that. Obviously, during the pandemic, that just didn't work. There's nowhere for it to be. So I started experimenting instead with a kind of robot rabbit that can appear in Zoom or whatever. But the main thing is that I'm using face.api to a machine learning model that you can just use. It's in JavaScript to read my expression. So this is me.
So this is me joining a Zoom meeting via Chrome browser.
I'll just skip ahead a little bit.
What I'm going to do is change to Chrome RabbitCam audio and Chrome RabbitCam video. Okay. So this is the Rabbit version of me. So what it's doing is reading the audio as it goes in and processing it, and then sending some signals to a 5x5 matrix in the Rabbit, run off Raspberry Pi. It also, and this is the machine learning bit, processes my expressions. So here's me smiling. I'm smiling. There we are. Here's me surprised. And here's me sad. I'm sure sad's working quite right. You could also do disgust and, I don't know, anger, if I can figure out how to express them in 25 pixels.
This expression detection model is used in a lot of places. Well, rather like the technique of expression detection, and is often it's called emotion detection or even sentiment detection. I think it's very controversial. There's also not many expression data sets to choose from, so likely if you come across something like this, they're all using the same one. Anyway, in conclusion to this section, it's really easy and fun to make these AIs. I mean, they're not really AIs. They're like simple text bots that respond plausibly, voice synths for talking, speech to text for listening. Again, that's an off-the-shelf ML model. Expression detection and emulation. And we've talked before about the different commercial equivalents. Text interfaces are pretty common now, simple chatbots on web pages, dreadful Tay that went horribly wrong on Twitter. Voice synths for talking, speech to text for listening, so Alexa and her ilk. And then expression detection, so and emulation. So there's quite a lot of stuff going on with VTubers where they kind of wear suits to get their expressions and posture and stuff like that, but you never see their face. But it's also because it's emotion detection, it can be used in interview for candidate selection and that kind of thing. The point of these, I totally find funny because it just makes me laugh a lot. So mine are obviously syntactic zombies with no understanding of the meaning of what they respond to, only the patterns in the surface, and I hope that's really clear that that's all they are. They're silly. But I'd argue that the difference between my little bestiary and commercial AIs is just money and effort, which obviously can make a huge difference. But it doesn't make a difference in kind. They just are these kinds of things. They don't have any common sense. They lack a sense of being a thing in the world, and they're shallow and easily confused. It's really, really obvious that they are not general AIs. They're just little machine learning programs. So I think that these experiments kind of edge towards an indication of something about a sleight of hand, which is affected by companies appropriating human-like interfaces for AIs. So they're reusing these kinds of human interfacing mechanisms to lend them a degree of both sentience, which they're not, and individuality, which they're not, that they don't deserve. So these aren't individuals, they're huge computer programs in the cloud that you're interfacing to like one tentacle of. And I think it's worse than that because people are comparatively brilliant, and to kind of, it hides, it blurs the line between the stupid machine and the comparatively brilliant human. And it also hides all the human labor that went into the data sets. Was that my time? Anyway, like Tristan, I think that we need to find better metaphors to explain AI's capabilities more honestly, and then to use these to inspire imaginative interfaces. And I think that statistical literacy is a really, really hard problem, and there's a lot of mathematics in these things which are really hard to explain. So it's not an easy problem at all. Anyway, I'll just spend like a minute talking about some ideas. And I wouldn't necessarily say that these are the best ideas either, but they're just some different routes into thinking differently about these things. So you might think of an AI as something like a giant distribution center, which needs to be designed, built, cared for, and maintained by an army of humans, even if some parts are automated. And then if you think about the kinds of interfaces that these big distribution centers have, they'll be formal, documented, inflexible, physical, contractual, monetarized. And so you might think about, well, when is this kind of thing appropriate? Well, perhaps it might be appropriate for formal, explainable machine learning contracts for job application filtering, where somebody might have a legal recourse to understand why they haven't been chosen for a particular job. If not now, then in the future. It's my favorite metaphor. I'm always drawn towards the natural world for metaphors, which is normally really terrible for machine learning because it's so much more brilliant than machine learning is. But I like the idea of a slug. So slug's pretty good at a bunch of stuff. It can find food, it can reproduce. It has some good basic behaviors within its limitations, but its interfaces are pretty simple and they're fixed. So if you think about some piece of machine learning that runs on your phone, doing photo classification or something like that, then that's the kind of interface that you might have there. It's fairly static. But it could still be improved by indications of certainty or undo, like the BERT ML model. And the final one, I was thinking about complex chemical filters. So imagine you've got a very complicated matching technology, perhaps specialized to a particular purpose, custom made, and then you've got specific custom complex interfaces, and you probably need a specialist to help you through them. So you might think about this as a kind of big media organization who needs a recommendation system, has custom data to make that happen. So again, I'm not sure that these are great examples, but they're different examples, which I think is really important. And I think they have a common thread, which is that, as I think we've all kind of been saying in a way, human interfaces to AIs need more friction in general, not less. Because using human-like interfaces is misleading and raises expectations further than they can be met. And that's me. Sorry if I overran. I forgot to start my timer.
Absolutely no problem, Libby. Fascinating presentation. I totally agree with your last statement, and I would like to invite Iulia to the, and normally we invite you to the stage, so invite you to the virtual stage for our panel discussion. And we have had quite a few questions from the audience. They have been upvoted by other people, so please, this is a request for the participants. Have a look at the questions and continue your upvoting, because I will start at the top. So the question that's currently at the top is Julia. To Julia, but Libby will undoubtedly have a view as well. Does your research mean that devices should change interaction modes depending on the task we ask them to do for us? Oh, you're on mute. You're on mute.
Can you hear me now?
Yeah.
Cool. Right. So yes, I believe that just as with any social system, we kind of expect different things from different people based on their roles or context. But this only applies to anthropomorphic AI. So if we're going to keep using that metaphor, and I believe when I started doing my research, I was also very vehement of the human-like metaphor being very misleading. And what I was noticing, and it probably ties in with Tristan's talk on people just don't care. I've noticed from experiments that in some contexts, people preferred more the human-like metaphor. Perhaps they were used to it. So then I sort of decided to detach from making that decision of whether this was a good metaphor or not, but rather looking at the interaction. So in an anthropomorphic kind of context, just how we expect different things from different people based on their roles or context. For example, you would not expect me to bring a glass of wine to answer these questions because we are in a context of a conference. Whereas if we were at a party, it would be quite rude not to bring a glass of wine. So, expectations change on context and the person you're speaking to. And my point is that anthropomorphic AI are social systems, and our expectations of these systems are really fuzzy. And as we're developing mental models that are new and particular to the situations, we must understand firstly what are our expectations of the role it is playing in the context which we are interacting with.
But do you think that there's a difference between, say, an AI that uses text on screen versus delivering the same message over synthetic speech?
I haven't tested that, but I would say that if it's in sufficiently human-like, then it shouldn't be a difference. I mean, we're used to texting on screen, as you would expect a human to be behind that text. So the human metaphor is quite prevailing, even if it doesn't have many cues in inducing that metaphor. It would probably be one of the first we're going to use.
Libby, would you agree with that?
I don't have much to add on that. I think Iulia has done far more research.
Okay. I was trying to get some, good conversation going, some controversy. That's okay. We have plenty of other questions. So the understanding, or there's another question here, the understanding of AI is tainted with storytelling, sci-fi, etc. But then so is COVID vaccination. Would you have any recommendations on how to reframe away from sci-fi or imaginary beliefs? And you can kick that off, Libby, because there's a question to both of you.
I totally get it. Is a real problem. And I think a lot of what technology's goals are governed by sci-fi. So Minority Report, for example, is so influential in the kinds of things that actually get made in the future or attempted to get made. I think it's a really hard problem. I think that's why I really support what Tristan's been doing about kind of trying to get people to think about what the alternatives are. The alternatives are, yeah, as I said before, just to think about non-human metaphors, and I don't know, employ some sci-fi writers. We've been considering whether we could do that, because yeah, they can have different ideas about what could be possible.
Julia?
Right. Whenever I was teaching this course on AI design, I have this quote that I always start with because I think it's beautiful and it works perfectly for this. It's a quote by Alice Walker, and it says, what the mind doesn't understand, it worships or fears. And I feel like it's very particular in this case, because most of us don't understand AI, so we're either worshiping it or fearing it. And I think this is a social psychological problem. I don't think it's down the realms of psychology. It's very little, perhaps, that we could do as technologists, designers, researchers that could change that. It's perhaps in our nature.
Okay, thank you. So there's another question to Libby, and it says here, I understand that different facial expressions can mean different things culturally. Could we train an AI to learn what they see, but also culture, so they can reply to how to talk to them?
You definitely could. Yeah, I mean, one of the problems with machine learning that I've found is just finding the data sets. So the data sets are always problematic. They've been reused. They're often gathered in ways that are quite unethical, and just sometimes there aren't any. And which is why I brought up the Face API data where you can just download it and use it. There's not very many like that at all. You could definitely do that if you wanted, if you had enough data. So it would just be the question of gathering that data and making it happen.
Okay, and a question for Julia is, have you also observed differences in the people who are interacting with the different AI models you presented, based on perhaps social or professional background of these people?
I have not, mostly because I have made a deliberate decision to not make this segregation in analyzing the data in the first place. But I will expect that differences exist, and I do take into account, such as the fact that when I did one of my first experiments, it was posted on specialized forums or Reddit, where people were tech enthusiasts. So I do expect their professional background made a difference, and perhaps with people that are not so enthusiastic about technology, or they haven't interacted with AI in the past, there would be a bit of a difference. So it's hard to test, because it's hard to make this segregation, I believe.
Yeah, yes, I personally feel that AI-based interactions need to be designed like any other user experience, by first fully understanding the audience, and then designing, and that also then includes their level of understanding of what AI can do, and whether or not it's important to them how it works, and then taking these things into account when you actually design something. Would you agree with that, Libby?
Yeah, I think probably there's quite a big age difference as well. I suspect that where if you've grown up with these kinds of tools on your phone or whatever, then you're much more familiar with them, and they're much more naturally part of your world. Whereas, yeah, and I don't know if that makes a difference to understanding. It's more about familiarity, I guess.
Yeah, and I personally also think that for the social context was with AI, if you use that in a conversation, then that opens up so many additional variables, including the cultural ones. And I'm probably one of the earlier adopters. So when Amazon Echo came out, I just had to try it. So I bought it, put it in the kitchen. I thought it was great, to say, hey, Alexa, please add milk to the shopping list. I loved it. My wife did not. Because, first of all, she didn't like me talking to a personal assistant who is a woman. And she said, can I not be switched to a man's voice? Because why does an assistant need to be a woman? And I had totally not thought of this connotation, because to me it was a machine, or maybe subconsciously ignored it, I don't know. I felt guilty when she pointed it out. So at the end, I was banned to the office. And then when Google came out, put Google in the kitchen, same functionality, but Google is Google, no problem. So to what extent should we avoid those social connotations in interfaces? Or should we actually do the other way around and exploit them to actually create a better interface.
Personally, I think it's completely horrific that no one put a lot of thought into that at all. And it's as Tristan showed. I mean, obviously, as a woman, I find it really, really upsetting that there's lots of female robots, white robots. It's all part of this, the unnecessarily gendered aspect of it. I think it's unnecessary anyway. I don't know what Iulia thinks, but I think it's the thoughtlessness that's the most difficult to deal with. I think that no one said, oh, okay, yeah, we're doing this, let's make it an option.
Yeah, I do think it's, as I was saying in one of the experiments, it is reinforcing harmful beliefs, but it would be good to kind of direct it towards a more neutral zone. But then what is neutral? So it starts getting into kind of areas of questioning human identity. What would be a neutral human identity, and that would place kind of a value in human society as well. So it's just becoming really complicated. So I think it's just easier to stick to kind of the old models that we knew, but but doesn't mean that they are any better. They're not perhaps better because they are reinforcing certain beliefs and stereotyping certain categories.
Yeah, it's easily done, unfortunately.
Yeah.
As part of the work that we did on synthetic voices, they merged for fun. For experimentation, they merged the male and the female voice together, and it actually quite interestingly genderless. So there's options.
Yeah. So another question from the audience, and this question is, can you please give some suggestions where we can use human-machine interfaces or gesture control systems in domestic or household appliances?
I don't know. Unless I've built them myself, I don't really allow them in the house, partly because I don't know what they're doing. So, and they're not explaining it to me. I don't have any in our house.
No, Iulia?
I mean, Google Assistant, Alexa, all of these are machine interfaces. They're not gesture control systems. I don't know of any in the home environment right now. They're usually using more this kind of assistant metaphor, the voice activated kind of metaphor, which they have made their way into our homes, but anything else, it's slower. I mean, robots, they're happening in Japan. Go to Japan.
Japan, it's a different area for robots.
Yeah, exactly.
Okay, so last question is to Libby, but I welcome your views as well, Iulia. So from your experiments, do you believe making the technology more accessible through simple tools like Google's JavaScript AI would help or hurt to understand the nature of these interfaces?
It's tricky. I mean, definitely, if you're willing to put some time in and you're relatively technical, then it gives you a much better understanding of what's happening. I've done a course on it, quite a lengthy course, and you come out of it going, well, machine learning is a bunch of hacks and assumptions. But you have to invest quite a lot of time to do that. And there must be some kind of intermediate educational aspect. This is what we were trying to get at with the birds thing. We didn't quite succeed because kids aren't really interested in birds. But there must be some intermediate thing which kind of abstracts out some of the problems and interesting aspects of it, we think. We're trying games at the moment. I've got a trainee who's writing some
Yeah, I personally think that demystifying AI definitely helps. Same, I'm also going through ways of like explaining like the basics of machine learning as well when I'm teaching, and it does help. But I know with myself that I will still anthropomorphize my computer or my Alexa. So there will be all elements of our human nature that will take over what we don't like, the gaps that we don't understand, and we will fill in kind of with these errored mental models. And that's always going to be tricky, even if you do understand it. But demystifying it will help to kind of stop putting it on this pedestal of AI will take the world. It's not going to happen in our lifetime, probably. Yeah.
Yeah. So should we all be empowered to start creating our own deep fakes of ourselves that Libby was creating? I've never thought of it that way. I always thought deep fakes was something negative. I never thought about creating an AI of myself. It's just mind-boggling idea.
Think about how many meetings you could go to, Leo. You know, you could really get a lot more.
All right. I'd like to thank you both for very interesting presentations and a very good panel discussion. And invite everybody to take part in the networking events that we have virtually. But given there's such nice weather, so the event officially finishes at 3:30. We can go over that a little bit undoubtedly. If you're in Cambridge and would like to have a bit of a taste of what networking used to be like, I will be in the tram depot opposite Anglia Ruskin from 4:30. If you do come over, I'll buy you a drink, and that applies to everybody. I might get very poor. I'm counting on not a lot of people being in Cambridge. No. Anybody?
I might grab the train.
Please come over, and I'll buy you a drink. All right. Thank you very much all for attending this event. I hope you enjoyed it, and I look forward to speaking to you virtually after this, or maybe even in person later. Thank you very much.
Thank you, Leo. Thank you, everybody. Bye-bye.
Gabby's going to take us back, are you, Gabby?